Okay, this is going on page 120 when we're done. All right, so I'm going to ask you something that's going to, or remind you of something that's going to seem kind of random, but I'm going to bring back to this. So we know that the square root of 16 equals 4. We all agree with that? Okay. But if I said that x squared equals 16, then what does x equal? Plus or minus 4, right? You give a different answer depending on how you're being asked. Because in your work, if we actually did the work, we'd write the square root of 16, but because it's given to you in two different ways, they're expecting two different answers, okay? So keep that in mind as we go through this, and I'll come back and connect to that in just a second. All right, so this says to graph the function f of x equals sine x below. All right, so for sine, we know we have a 0 at 0, we have a 0 at pi, we have a 0 at 2 pi. Then at pi halves, we're at what? 1. At 3 pi halves, we're at negative 1. Okay, so let's draw this in here. Ugh. Okay, so there's our sine. So then it says, give the solutions to the equation. Okay, so here's where I want to come back up here real quick. The sine inverse, yeah, well, we're only going from 0 to 2 pi. The sine inverse of 1/2, what is that? Pi 6, okay? The sine inverse of 1/2 is pi 6, right? And if I ask you for the sine inverse or tangent inverse of any value, then you can only give me answers from negative pi halves to pi halves, right? And if I ask you for the cosine inverse, you can only give me answers from 0 to pi, right? And so it comes back to kind of this kind of thing. We're being asked things in two different ways. This asks me for the sine inverse, and the answer is pi 6, and that's it. This asks me for the solutions to this equation on this interval. That's a different thing, because how many times is sine going to equal 1/2 from 0 to 2 pi? Twice. It's about right here and right here. And I say about because your curve's not going to hit it exactly, but it happens twice. So you're actually going to give two answers to this because it's more like solving an equation than it is just giving an exact value. Does that make sense to you? Okay. So that means that x here, it's going to be pi 6 and what? 5 pi 6. Okay. We okay with that? All right, so then it says, give the solutions to the equation sine x equals 1/2 on the interval from negative infinity to infinity. So it's not just one time around the circle, it's the entire graph of sine, right? So what we have is, here's our unit circle. We have one at pi 6 and at 5 pi 6 when we went from 0 to 2 pi, right? And now whether it's, from negative infinity to infinity, it's still going to hit those two places. We just call them different angles because we just keep rotating around, right? So when I'm here and I rotate around to get back here, how far did I go? 2 pi. Or if I go this way, how far did I go? Negative 2 pi. And then here, same thing, 2 pi or negative 2 pi, right? And so I can just do the plus or minus thing, and then we're going to use that n again. So x is equal to, and I'm going to write this in a little bit of a different way than we did the other day. I'm going to have to say that n is an element of what? The integers, right? Such that I get pi 6 plus or minus 2 pi n and 5 pi 6 plus or minus 2 pi n. And I'm not going to make you write the n as an element of the integers every time. We're just going to kind of assume that for the rest of what we do, okay? Okay, but n has to be an element of the integers, and so I can add or subtract 2 pi and any multiple of that to get back to that point. So that's all of my answers from negative infinity to infinity, and there's an infinite amount of answers. Okay, we good? All right, so then a trigonometric equation, that's what we're doing here, can have one solution, no solutions, or several solutions depending on the defined intervals. So we have to pay attention to the intervals that we're given. So it's to solve a trigonometric equation, we isolate the trigonometric function. So you get it by itself, then we can solve it. So on this one, we're not using our identities at all. It's pure algebra, okay? Which could be a good or bad thing for you. I don't know. All right, so let's look at number 1. I've got 5 cosine x plus the square root of 2 equals 3 cosine x. So I can subtract this 3 cosine x from both sides. What will that leave me over here? 2 cosine x plus the square root of 2 equals 0. Then I can move over the square root of 2, so 2 cosine x equals negative square root of 2. So cosine x equals negative square root of 2 over 2. And then this is going from negative infinity to infinity, right? So x, when is the first time on the unit circle that I get negative square root of 2 over 2 for cosine? 3 pi fourths. So I will get 3 pi fourths plus or minus 2 pi n. Then when's the next time? 5 pi fourths. Yeah. 5 pi fourths plus or minus 2 pi n. And guess what? Still got to know your unit circle. So if you never really knew it, you're still not going to be able to do anything. Okay. We good? All right, so let's look at number 3. I got 3 tangent theta plus 2 square root of 3 equals 8 square root of 3 minus 3 tangent theta. So are those 3 tangent thetas going to cancel out? No. But if I add 3 tangent theta to both sides, I get 6 tangent theta. And then if I take this 2 square root of 3 and subtract it from both sides, that'll give me what on the right-hand side? 6 square root of 3. So then when I divide both sides by the square root of 3, I'm going to get tangent theta equals square root of 3. Okay, so I'm going from negative infinity to infinity. Let's think about our unit circle here. On the unit circle, when does the tangent value equal square root of 3? Pi thirds, and when else? 4 pi thirds. So here and here, right? So when I'm at pi thirds, how much of a rotation do I do to get to 4 pi thirds? Pi, right? From here, so I can go from here all the way around, that's 2 pi, but from here to here, that's pi. And from here to here, that's pi, right? Up here, it didn't work that way. This isn't pi, right? Pi would put me down here, and that's not the same thing. For sine and cosine, the period of the function is 2 pi. What's the period of the function for tangent? Pi. This is why, okay? Because I don't have to put both of these values like I did for sine. All I have to put is pi thirds, and it's every pi, right? Plus or minus pi times n. Because your period is pi for tangent, so that hasn't changed. Okay? No, because if I add pi to this gives me 7 pi fourths. Oh, this? Well, that's what I did. 3 pi fourths plus or minus 2 pi n. Because for cosine, you got 3 pi fourths, which is right here, and 5 pi fourths, which is right here. So if I take this and add pi, I end up down here. I don't end up over here. So I have to do this one. I have to make a full rotation. I can't, in whatever I add here, I'm not adding the same amount. Okay, does that make sense? It has to be a uniform amount. Okay, we good? So all you have to remember is the periods just like you already know, so it's not that big of a deal. Okay. All right, so let's look at number 3. I have cosecant alpha minus 6 over 4 equals negative 1. So what should be the first thing I do here? Multiply by 4. So I get cosecant alpha minus 6 equals negative 4. That means that cosecant alpha equals 2. Now, once you get the trig function isolated, then I would make them all into sine, cosine, and tangent because it's just easier for your brain. So what's the reciprocal of cosecant? Sine. So that means that the sine of alpha is equal to 1/2. Now, in this case, I'm only going from 0 to 2 pi. It's just one rotation around the circle. So how many answers will I have? 2. So when is the first time sine is 1/2? Pi 6. And when is the next time? 5 pi 6. That's it. Okay, what questions do you have? All right, let's look at number 4. because it's going from 0 to 2 pi. All right, number 7. Not number 7, number 4. We got 7 secant y equals secant y minus 4 square root of 3. So I would subtract secant y over there, so it's going to give me 6 secant y equals negative 4 square root of 3. Then I'll divide both sides by 6. So secant y equals negative what? 2 square root of 3 over 3. What is the reciprocal of secant? Cosine. So the cosine of y is equal to negative what? Square root of 3 over 2. All right, so here again, we're going from negative infinity to infinity. So y is equal to, when's the first time on the circle that I get negative square root of 3 over 2? 5 pi 6. Then this will be plus or minus what? 2 pi n. And then when's the next time it's negative square root of 3? 7 pi 6. And then plus or minus 2 pi n. Okay. Everybody good so far? Okay. We're going to do a whole bunch of these because all these little different algebraic things happen and different things happen with your answers. So, all right, number 5. We have 3 tangent A equals tangent A minus 2. So I'll subtract tangent A from both sides. So I get 2 tangent A equals negative 2. So tangent A equals negative 1. Negative 1. So this is going from pi to 3 pi halves, which is just that part right there. So where in that interval is tangent negative 1? Never. Why never? Because it's positive in the third quadrant. Because we only have the third quadrant there, and tangent's positive in the third quadrant, right? So that means A is equal to the empty set or the empty set that way, either way. My interval restricts me to the third quadrant, and in the third quadrant, tangent's positive, so I don't have this equation does not give me anything there. Okay? I have no answer. Right, it's the empty set or empty set. Because this is restricting me to the third quadrant, because our answers are in set notation. So there is an answer. It's the empty set. Okay, number 6. I've got 4 sine squared u plus 8 equals 11. So I'm going to start by subtracting 8 because my algebra steps are exactly the same as anything else you ever do. Sine squared u equals 3. So sine squared u equals 3/4. So sine u equals what? Close. There you go. Plus or minus square root of 3 over 2. So then I need an answer for u. And this, again, is just pi to 3 pi halves. So we're only in the third quadrant. So when does it equal positive or negative square root of 3 over 2? 4 pi thirds. What questions do you have? Awesome. All right, flip it over. So number 7, 4 cosine squared x minus 1 equals 0. What is it that you have before you here? Difference of squares, yes. So we can factor this thing. And we get 2 cosine x plus 1, 2 cosine x minus 1. So once I have it factored, then I can use my zero product rule. And we know that 2 cosine x plus 1 could equal 0, or 2 cosine x minus 1 could equal 0. So 2 cosine x equals negative 1. Cosine x equals negative 1/2. And then over here, 2 cosine x equals 1. So cosine x equals 1/2. Now we're going from 0 to 2 pi. So it's just one rotation around the circle. Cosine, when is cosine negative 1/2? 2 pi thirds, and what else? 4 pi thirds. And when is cosine positive 1/2? Pi thirds and 5 pi thirds. So once you have your separate solutions, then you put them all together in order. So this would be pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds. Oh, pi thirds. Okay. We good? What questions do you have? All right. So let's look at number 8. I've got cotangent x equals cotangent x times sine squared x. So I have a quadratic. I clearly want to get everything to one side of the equal sign, so I'm going to move this over to the right. So we get 0 equals cotangent x times sine squared x minus cotangent x. So what can I do next? Factor out the GCF. 0 equals cotangent x times sine squared x minus 1. Difference of, I was about to put equals 0. Got difference of squares again. All right, so 0 equals cotangent x times sine x plus 1 times sine x minus 1. So now I'm going to split that into 3. So this gives me cotangent x equals 0. This would give me sine x plus 1 equals 0. Sine x minus 1 equals 0. All right, so then cotangent, I want to make it into tangent. What's the reciprocal of 0? Undefined. So the tangent of x equals undefined. Here, sine x equals -1, and sine x equals +1. Now, I'm only going from pi to 2 pi. So I would suggest, like, actually literally drawing whatever section that is so that you can think about it. So in that interval there, when is the tangent undefined? 3 pi halves. So x would equal 3 pi halves. When is sine -1? 3 pi halves. And in that interval, when is the sine 1? Oh, I put 3 pi thirds. Okay, that's good. Yeah, pi halves. So your answer is just 3 pi halves. I didn't have to put empty set because it wasn't like the final answer. Does that make sense? Yeah, no. Because it's not in the interval. Yeah. Everybody okay with that? All right, good. So let's look at number 9. If 3 tangent squared u minus the square root of 3 tangent u equals 0, so what could I do here? Factor out the GCF. So tangent u times 3 tangent u minus the square root of 3 equals 0. All right, so I've got it factored. I can use my zero product rule. Tangent u equals 0. 3 tangent u minus the square root of 3 equals 0. So 3 tangent u equals square root of 3. Tangent u equals square root of 3 over 3. Okay, so here I'm going from pi to 3 pi halves, just that part of the circle. So from pi to 3 pi halves, when does tangent equal 0? At pi, okay? And when does the tangent equal square root of 3 over 3? So pi 6th angle, and then that third quadrant will give you 7 pi 6. And then that's it, right? So then u is equal to pi and 7 pi 6. Okay. What questions do we have? Nothing. Okay. Number 10, sine x secant x plus 2 square root of 2 sine x equals square root of 2 sine x. So what do you think we could do first here? Yeah, I would move over, I would set it equal to 0. Before you factor out a GCF of anything, you want to get everything on one side. So I'm going to move this. So I'm going to get sine x secant x plus, and then what would that leave me? Square root of 2 sine x equals 0. Now that it's equal to 0, now I can factor stuff out, and I can factor out the GCF. So this is going to give me sine x times secant x plus the square root of 2 equals 0. Then I can use my zero product rule. So sine x equals 0. Secant x plus the square root of 2 equals 0. I subtracted 1 away. So then secant x equals negative square root of 2. What's the reciprocal of secant? Cosine. So cosine x would equal negative what? Over 2. Good. All right.
Teachers, students, please write a solution. Teachers in the West Wing in early college.
Okay, so from 0 to pi, when is the sine of x 0? 0 in pi. And when is the cosine negative square root of 2 over 2? 3 pi fourths. Good. So then x is equal to 0, 3 pi fourths, and pi. Okay. Everybody good with that? Awesome. So let's look at number 11. We've got cosecant squared plus 5 equals 7 minus cosecant theta. So this is a quadratic, so I've got to move everything to one side. I want to leave this positive, so we'll move it to the left. Cosecant squared theta plus cosecant theta minus 2 equals 0. So this is a quadratic. I need to factor it. So I'm going to factor it into two binomials. Get cosecant theta and cosecant theta. And I will give you just a second to finish that. Plus 2 minus 1, because algebra. Okay. All right, so now that I've got it factored, this gives me cosecant theta plus 2 equals 0, and cosecant theta minus 1 equals 0. Cosecant theta equals negative 2. Cosecant theta equals 1. All right, what's the reciprocal of cosecant? Sine. So the sine of theta is negative 1/2, and the sine of theta is 1. This interval is going from 3 pi halves to 2 pi, which is just the fourth quadrant. So when would sine be negative 1/2? 11 pi 6. And in that interval, when would the sine be 1? Never, right? So this doesn't even give me anything, so my answer is just 11 pi 6. Yes? Awesome. Okay, so number 12. 2 sine squared alpha plus 3 sine alpha minus 2 equals 0. So it's a quadratic. It's already set equal to 0, so you just need to factor it. So I'm going to give you a minute to factor it. Okay, so that's what you should get. 2 sine alpha minus 1 times sine alpha plus 2. Okay, because factoring. All right, so then 2 sine alpha minus 1 equals 0, and sine alpha plus 2 equals 0. So 2 sine alpha equals 1, sine alpha equals 1/2, and then sine alpha equals -2. All right, so this is 0 to 2 pi. We're going one time all the way around the circle. When is sine 1/2? Pi 6 and 5 pi 6. When is sine -2? Never. That doesn't even make any sense, right? So alpha is equal to pi 6 and 5 pi 6 only. You have a question? You figure it out? Well, ask me your question. Oh. Uh-huh. Okay, but you got to remember, whatever you put in here, these two have to multiply together to give you that. So if you're going to do the 2 times -2 to get -4, you have to do grouping to get it out of there. Yeah. All right, number 13. So I have secant to the 4th x minus 4 secant squared plus 3 equals secant squared minus 1. All right, so for sure I want to get it all to one side, so I'm going to move everything to the left. So I have secant to the 4th x. Then I've got minus 4 secant squared, but there's 1 right there, so it's actually going to be minus 5 secant squared, secant squared x, and then plus 4 equals 0. All right, so this is a quartic, but can I treat it like a quadratic? Yes, so I can factor it like a quadratic, so go ahead and do that. It's secant squared x and secant squared x. They'll both have to be negative, right? It's going to be, what are my two numbers going to be? Good. 4 and 1, or 1 and 4, doesn't matter. Okay, now each one of those is a what? Difference of squares. Okay, but I'm not going to factor this one this way because I'm going to do it a different way, and I'm going to tell you why the different way isn't always best for everybody. But I can just go ahead and split it up here. So I get secant squared x minus 4 equals 0, and secant squared x minus 1 equals 0. So then secant squared x equals 4, and secant squared x equals 1. So when you go to the next step, secant x, if you think the answer is 2, you shouldn't do it this way because the answer is not 2. What is it? Plus or minus 2. Whereas if you actually factor it into the difference of two squares, you have two different equations that gives you a positive 2 and a negative 2. Okay, so you know whether or not you can handle this. You've got to be honest with yourself. So here, secant x is going to equal what? Plus or minus 1. And just because you can think it and do it right now, you got to be honest with yourself. Are you really going to do that when it comes down time to do it or not? You know, it's up to you. All right, what's the reciprocal of secant? Cosine. So cosine x equals plus or minus 1/2, and cosine x equals plus or minus 1. We are only going from pi to 2 pi. So when is cosine in the, so if it's plus or minus, it's going to be all the quadrants. So in the third quadrant, when is cosine 1/2? 4 pi thirds. And what about the fourth quadrant? 5 pi thirds. Okay. And then when is cosine plus or minus 1? Pi and 2 pi. Good. And then you need to put them in order. So this is going to give me pi, then 4 pi thirds, 5 pi thirds, and 2 pi. And if this had gone from 0 to 2 pi, make sure that you're putting in there 0 and 2 pi for that, something like that, so it kind of shows up twice. Okay. We good? All right, so let's look at 14. Tangent cubed y plus tangent squared y minus 3 tangent y minus 3 equals 0. Okay, so I've got a cubic. It's not the sum or difference of cubes, and I have 4 terms. How do I factor something like this? Grouping. Good. So I'm going to group these, and I'm going to group these. So I can factor out the tangent squared. That leaves me with tangent y plus 1. I can factor out a negative 3, and that leaves me with tangent y plus 1. Okay? So then that means I get tangent squared y minus 3 times tangent y plus 1 equals 0. So tangent squared y minus 3 equals 0, and tangent y plus 1 equals 0. So tangent squared y equals 3, so tangent y equals what? Plus or minus square root of 3. Very good. And then tangent y over here equals negative 1. All right, so I'm going from 0 to pi. So when in that will tangent be plus or minus square root of 3? Pi thirds and 2 pi thirds. And when in there would tangent be negative 1? 3 pi fourths. Very good. All right, so then y is equal to, we know pi thirds comes first. What comes next? 2 pi thirds. Good. Got to kind of picture the unit circle. And then 3 pi fourths. All right. What questions do you have? Algebra, algebra, algebra. That's all it is. Okay? Really, the only trig part of it is for you to be able to come up with the unit circle values. So, we good? Any questions? All righty.